Hi guys, this video will be a couple examples of solving quadratic inequalities. So I have the first one, a pretty basic one to solve. X squared minus 3x minus 10 is greater than 0. So the first thing I'm going to show you is if you're working through it algebraically, and then we'll look at graphically, and you can kind of choose which way you want to do. For these, when I teach this in the class, we usually do graphically. It's actually a little bit easier. So I'm going to start by looking at this as if it were an equation. Okay, so I'm going to take just x squared minus 3x minus 10 equals 0. Okay, if I can figure out what values make this parabola, this quadratic, equal to 0, then I can easily figure out where it's greater than 0 or less than 0. So I want you to think about this, that this is a parabola, and what I'm doing right now is finding where it crosses the x-axis. And then what I'm going to do at the end is really figure out where it's above the x-axis, okay, since I want it to be greater than 0. So this is, most of these are nice and factorable. I can't say all of them, but most of them are. Okay, so I've got this, and this is going to factor into minus 5 plus 2, okay, to get everything we need. So we have x equals 5. And x equals negative 2. Okay, so that would be my solution set, just those 2 points if it was an equal sign. So this is greater than 0. We want the values of x that are going to make this whole thing greater than 0 to make the output more than 0. Okay, so what I'm going to do next is I'm going to test a couple points. I only have 2 options really for this. If that 5 and negative 2 make it equal to 0, either inside negative 2 and 5 are going to be greater than 0, or outside negative 2 and 5. So I'm going to pick a value right now, and I'm going to pick what we call test values. Alright, so let's try a value like, I'll take x equals 2. Okay, that is in between negative 2 and 5. So if this works, then I know that my solution for this one's in between negative 2 and 5. So let's plug in to the original equation 2. So I get 2 squared minus 3 times 2 minus 10. Let's see what we end up getting out. So we have a 4 minus 6 minus 10. Okay, so we have a negative 12. Okay, so if I plug in a 2, I get out a negative 12. Okay, so that is not greater than 0. My output's not greater than 0. So I know my solution set is not in between negative 2 and 5. My solution set, oops, sorry about that. Let me rewrite that. My solution is outside of negative 2 and 5. Okay, so outside of negative 2 and 5 would be all my values from negative infinity all the way to negative 2. And I'm going to leave out all the numbers in between negative 2 and 5, and my solution will be all of these values in 5 to infinity. So all of those values will make this, the output of this, be greater than 0. Okay, so let's look at it graphically for a second. Okay, so let's see. If I were to draw this, you can draw this on your calculator, although by now you know how to graph these by hand. This is going to be really just a quick sketch, nothing too detailed for what we need to do. Alright, so we just figured out that at negative 2 and at 5, this is where the graph equals 0. Okay, and this one opens up, we knew, because it was a positive x squared. So, and I think the y-intercept, if I remember correctly, it was down here. I'm just going to kind of estimate it down at negative 10 here. Okay, so I know my graph is something like this. All I really need is a sketch here. Just pretend that went through negative 10. Okay, if you see, so this green point's right here. That's where the graph equals 0. So I'm going to circle all of this space right here, and all of this space. This is where my graph, my output, is greater than 0. Okay, and that's what we said. So that means all the values of x from negative infinity all the way up to negative 2, but not including it, so I have a soft bracket. And then union all of these other values on the right that pick up from 5 to infinity. Okay, if I wanted my output to be less than 0, then I would pick the lower half of this. Okay, so I'm going to show you just one more quick little example. I won't probably do the whole thing, but let's say where I have a negative in, so this is going to open down. So if you're doing this graphically, you just have to look at the graph and see where, in this one, we would want the graph to be above the y-axis. But if you're going to do this one algebraically, what I'm going to do is I'm going to go through the entire thing with a -1. Okay, it's not going to be the same graph, but it will give me the same solutions here. So if I go through with a -1, I get an x squared plus 2x minus 8. Okay, I'm changing all my signs, including this inequality. Okay, so it's not to say that the one with the negative and the one with the positive are the same parabolas, but they do have the same same x-intercepts. So I can still find my x-intercepts the same way. Okay, so if you solve this one, and I do x and x plus 4 minus 2 less than 0, so I get x. So I'm going to treat it like an equal sign for now to get x equals -4, x equals 2. Okay, if I do my test points, we will find that the values inside -4 and 2 for this one are the ones that are going to get me values less than 0. So my solution set would be in between -4 and 2. Okay, so if you do this one graphically, start off with the original one with the negative in front, the one in green, and that one you're going to be looking for the y values to be above the y-axis because that one still had the greater than sign. But if you then go through with a negative like I did in white, okay, then I would be looking for this white parabola to be lower than the x-axis because I changed my inequality to a less than when I went through with the negative. So it really just depends on which way you're doing it. Either way will get you the values in between -4 and 2 is where you have the right input values that you need.